Everybody should have these ones in front of them. Put your assignments to the side. We're going to be talking more about rotation. Okay? We said that rotation is the one where you have some image and you just turn it some amount. All right? Still stays the same image, it's just being turned. Okay, so today's definition is that a rotation about some point O through an angle of x degrees is a transformation that maps each point P of the plane with a point P prime. So remember, P and P prime are pre-image and image. Right? Okay, such that the measure of angle POP prime, so the point we rotated around, and the old, the angle that those 3 points would form, should be equal to those x degrees that they're referring to up here. And your new piece should be equal to your old piece, right? We said that it doesn't change size, it just turns, okay? So it says point O is what we will call the center of rotation. Which basically just means any rotations that happen are going to be based on that point. So we'll be going in a circle either clockwise or counterclockwise, whichever way they tell us, around that center point. Okay, and x degrees is going to be called your angle of rotation. And they'll specify how many degrees you should be rotating each time. Okay. Okay, so keeping that in mind, on example 1, they say if PQRST is a regular pentagon and O is the center of that polygon, they want us to find A, B, and C. Okay, so if it's a regular pentagon, that means what about its size? 5, and they're all going to be equal, right? Okay, and it says O is the center, so that's going to be the point that we are rotating around. Okay? So, the first thing they ask us to do is the 72-degree clockwise rotation about O of point Q. So I'm supposed to be rotating point Q around O 72 degrees. Okay, so what we also should note is you guys said all of our sides were congruent, right? So if I was making angles, each one of these points and the center makes its own angle, right? And if all the sides are the same, then all of those angles should also be the same, okay? So if I'm rotating in a circle, that's how many degrees? 360, very good. And if I divide that 360 degrees up amongst the 5 different angles, it should tell me how many degrees each section of this is worth, right? So what is 360 divided by the 5? Very good. So now I know each one of these sections is 72 degrees. Okay, so it says that I'm starting at point Q, right here, and I'm rotating clockwise 72 degrees. That means I'm going to end up where? Point P, right? Because we said from here to here is 72 degrees. Each section is 72 degrees. So if I'm at Q and I go clockwise, that would put me at point P. Okay? All right, B says that they want us to go 144 degrees counterclockwise, starting at point R. So counterclockwise would mean the other direction. Point T, right? Because 144 would be 2 of these, right? So 1, 2. That would put me at point T. Very good. Okay. And then problem C says they want us to go 360 degrees clockwise of point P. Right. If I go 360 degrees, that's the whole thing, right? I'm coming right back to where I started. So if I start at point P and I go 360 degrees, I'm going to end up right back at point P. So we're going to be able to use this idea to help us figure out how many degrees every section is worth in a figure. It's just going to depend on how many sides the figure has. Right? So that can change depending on the size of your figure. Okay. All right, next section says to find the rotation of each image, of each segment or triangle. So we've got a few different things going on here. We see we've got these 4 squares here. We got one really big square turned diagonally, and we've got all these little triangles that they're talking about, right? Okay, so it says first on A to go 90 degrees clockwise and rotate about the point Q of JK. So my point Q is right here in the middle, right? So I am rotating about the center of this shape. Okay, so JK is this piece right here. Okay, and it's part of this square. Right? How many sides does the square have? 4. Okay, so 360 divided by 4 is 90. So if I'm going 90 degrees, I'm basically going 1 square worth, right? 1 side. Okay, so what's important to remember right here is that if I'm going to rotate 90, I'm rotating around Q, right? I'm not just turning this shape right where it's at, right? I'm rotating around the point Q. So if I rotate 90 degrees, and I'm right here, I'm going to rotate and turn sideways, but I also move down, right? Because I'm going around Q. Okay? So if JK is at the top right now, and I have to turn it and move down, JK would end up where in this square? Very good. On the side, right? Because it had to turn and shift down if it's rotating around Q. Okay? So it would end up at LA. Very good. Okay. All right. B says a 90-degree counterclockwise rotation, again, about Q, of the triangle HIP. So HIP is this triangle right here. This time I'm going counterclockwise, which would mean back, right? Okay, so again, it's in this square here. If I rotate back 90 degrees, I'm going to turn and come down, right? It's right here, HIP. It's all part of this figure, right? So if I turn this, I'm turning it and moving down, right? So I'm not just sitting in one spot, spinning on top of itself. I'm rotating around Q. So it was here, now it's here. Okay? So HIP would end up on top of what down here? Right, this one right here, whichever combination of the 3 letters you use. So triangle, FON, NOF, whatever. Okay. Okay, so the thing is that let's say this pin was what was rotating. It's right here, so if I rotate 90 degrees, not only does it turn, right, it turns and comes down. Right? That's why we have to be keeping in mind we're not just spinning on top of ourselves in a circle, right? I'm rotating about the center here. So it's going to come all the way around. All right. C says 180-degree rotation of the line segment FM. Okay, so FM is this one right here. Okay, if I go 180 degrees, it doesn't matter which direction, right? Because either way, that's half of a circle. Okay, so if this is in the bottom, okay, when it goes, let's say it moves this direction, we're going to go counterclockwise. Then right here, it would turn and come up, right? But then to move one more, because it didn't just say 90, you'd have to turn again and move over. And it would be where? BI or IB, yes, very good. Would end up right here. Okay? If I rotated it once, it would have been right here, right? The second time ends up over here. Okay. All right, then the last one says 90 degrees clockwise rotation, but they're changing our point of rotation. All right. Now they say we're rotating around point P, which is right here. So I'm spinning on point P. Okay. All right, so HOP would be this triangle here. If I go a 90 degrees clockwise rotation, okay, then I end up at triangle. Very good. Okay, so we were here. If I rotate 90, I just end up on the triangle right above it because now P is our center instead of Q. All right. Okay. So in the next section, they give us another definition, and this definition says that a figure is said to have X degree rotational symmetry if the figure can be rotated about X degrees points so that the pattern appears identical to its original position. Okay. So what's important for us to remember here is that rotational symmetry can't be greater or can't be larger than 180 degrees. So we're going to make a little note of that here. Our X degree can't be larger than 180 degrees. Okay. So it says, for example, a square has 90 degrees and 180 degree rotational symmetry. Okay, so to find rotational symmetry, we're going to follow 3 steps. Our first step is going to be to find the number of lines of symmetry that that figure has. So find number of lines of symmetry. Okay. Once you have determined how many lines of symmetry you can find in that figure, step 2 is going to be to take 360 and divide it by the number of lines that you found. So 360 divided by number of lines of symmetry. And then our third step is once you have divided, that you're going to list all the multiples of whatever number we get once we divide that are less than 180 degrees, or less than or equal to 180 degrees. So list all multiples of your x that are less than or equal to 180 degrees. Okay, so before we give it a try on one we don't know if it's right or wrong on, they told us that for this picture, these are your answers, right? The 90 and the 180. So let's try these 3 steps on this figure to see if that actually works. So in this figure, how many lines of symmetry could we draw? Where all could we put them? What did you say?
4 lines.
Right. So we could draw here and here, right? And we also could go corner to corner. Good. Okay, so according to this rule, it says we would draw 4 lines. I'm supposed to now take 360 and divide it by the number of lines we came up with. What is 360 divided by 4? 90. Okay. So now it says you just list all the multiples of whatever you got that are less than or equal to 180. So my first multiple would be 90, right, which they had. And then that was just 90 times 1. What's 90 times 2? So that would be my second multiple, and it is less than or equal to 180. But that would be all we can do, because after that, it's too big. So it does work. So those are the 3 steps we're going to use to find our rotational symmetry. Okay, so example 3, it says describe the symmetry of each figure, include the number of lines of symmetry and the rotational symmetry of 180 degrees or less. Okay, so starting with figure A, how many lines of symmetry could we draw? Where could we draw? Where at? Okay, down the center. Okay, and where else? Like there to there? And then also we could do all point to point. Good. Okay, so how many did we just draw there? 8 altogether. Okay, so 8 lines of symmetry. That would mean we're going to have 360 divided by 8, which would give us 45. So now we list all the multiples. Well, 45 times 1 is just 45, so that's our first one. Okay, what's 45 times 2? 90. And 45 times 3. Good. And 45 times 4, 180. And we could keep going, but would they be less than or equal to 180? No. So that's all the ones we list. Okay, so it wanted the number of lines of symmetry, which is what we got right here. And then we listed all of our rotational symmetries. Okay, all right, on B. How many lines of symmetry can we draw on figure B? Just one down the middle, right? Because if I try and go side to side, top to bottom, the top is bigger than the bottom, right? Okay, if I try and go corner to corner, not going to work. Okay, so I would divide 360 by our number of lines, which is just 1. And what is 360 divided by 1? 36. And is that less than or equal to 180 degrees? No. So this one has no rotational symmetry. Okay. All right, C is kind of like one of the ones we had on our 2.6 notes that we drew lines of symmetry through. How many can we draw on C? 5. Very good. So I would have 360 divided by 5, which is 72. And then we just write down all the multiples. So the first one would just be, right, and what is 72 times 2? 144. Right, because if I go one more time, I wouldn't be less than 180. So we just stop there. Okay. Figure D, how many lines of symmetry do we have there?
2.
So here and here.
It looks like you can't get that diagonal. It's more a table.
I think it's supposed to be like a square, so we should be able to go corner to corner. Yes, so we are going to have 4. So I got 360 divided by 4, which is 90. Good. So what would my multiples be?
90 and 180.
90 and 180. Very good. All right. Okay. Once we got those, let's flip it over onto the back. Okay, so rotation coordinates for 90, 180, and 270 degrees if you go counterclockwise. Okay, so we always start with some original point x, y. If I rotate 90 degrees counterclockwise on a coordinate grid, my new point should be negative yx, which means we flipped their spots and changed the sign of y. Okay? If I go 180 degrees, I start at my original point xy. 180 degrees would be halfway, right? So it should be just in opposite quadrant of wherever it is currently, which would mean all I'm going to do is change the signs. Okay, and then lastly for 270, again we start at our original point. Okay, and I am still switching x and y, but this time change the sign of x. Very good. Okay, and we'll be able to prove that this is true or not because we already know what the signs are for x and y in each quadrant, right? So we'll be able to determine if this rule works or not. All right, so example 4 says these are our image points. So these are the original points. I'm going to go ahead and come plot these over here. So A is at 3, negative 4. Okay, and B is at negative 2, 1. And C is at negative 3, negative 4. Okay, so on part A, it says that we are rotating 90 degrees counterclockwise about the origin. So I'm rotating right here around this center point. So for point A is right here. If I rotate 90 degrees counterclockwise, what quadrant do I end up in? 1. Right, I would rotate up to this quadrant, right? Okay, and I'm going to use this rule right here to determine my signs. Okay, so if this was the original coordinate point, our rule says to switch the x and y, but do what to the y value? Make it opposite. So my y is already a negative 4, so it's going to become a positive 4. Okay, so this has a positive x and a positive y. In quadrant 1, is everything positive? Yes, so that makes sense. So there is my A prime. Okay, for B, right now B is right here. If I go 90 degrees counterclockwise, what quadrant is that going to put me in? 3, right? Okay, so we know everything in that quadrant is supposed to be negative. Let's see if our rule gets us that. Okay, so here's my original point. I have to change the sign of my y. Currently, my y is a positive 1, so it's going to become a negative 1, and then I need to switch their spots. So would that fit in that quadrant? So we are at negative 1, negative 2 for our B prime. Okay, and then lastly, point C, negative 3, negative 4. If I go counterclockwise, where is that going to put us? Quadrant 4. Okay, so I know my x's are positive here, but y's are negative. So I have this point. I'm going to change the sign of y, which is going to make my negative 4 positive, and then flip their places, which would make it 4. And would that fit in that quadrant? So that makes sense. Okay, and we're actually going to make B our double prime column because that's going to be the second one to draw. That way we can keep them differentiated from what we've already drawn. Okay, so for 180, our rule was keep your coordinate point in the same order, just change the signs, right? Okay, so A was originally at 3, negative 4. If I rotate 180 degrees, I'm just going to change the sign of my 3 to be negative 3 and my negative 4 to become, okay. So A was originally here. If I go 180 degrees, that should be here. That makes sense, right? Negative x's, positive y's. So there's my A double prime. Okay, for B, again, just changing signs. So what's my B double prime going to be? 2, negative 1. Very good. So, and that makes sense, right? So if I move 2 quadrants, that would put me here. All right, and then for C, I was originally at negative 3, negative 4, so my new point is going to be good. which makes sense because if I was here, I should end up here if I go 180 degrees. Okay? All right. All right, last question. It says that we're going to graph the line given by the equation y equals negative x plus 3. So let's go ahead and do that first. If I'm graphing this line, where is it going to start at? Positive 3 on the y-axis, and then my slope tells me I'm doing what? Okay, so it's something like this. This is our old line, or our original line. Okay, it says then find its image under a 90-degree clockwise rotation about the origin, right? The equation of its image. Okay, so a couple things we need to keep in mind. It says think. A 90-degree rotation forms a what kind of angle? A right angle, right? A 90-degree or a right angle, very good. What kind of lines form right angles? Perpendicular, good. So we know we're going to need perpendicular lines. Okay? And what do we know about perpendicular lines and their slopes? They're opposites, very good. So slopes are opposite. Okay, so if my slope is opposite of -1, what would that be? Positive 1. So my y prime, or my new equation, has a slope of positive 1x, right? Okay, so the coordinate point 3 is 0, 3, right? Okay, so if we are rotating 90 degrees, then if it was here, I should be at -3. Okay, if I'm going backwards. So that would put me at a y-intercept of -3. Okay, so now I'm just going to graph this. So it starts here, but has positive slope. And since those are opposites, it should form that 90-degree angle.